guys, welcome to Coding Ambitions. In this video, we'll learn about how we can add iOS support in the Android Jetpack Compose app, right? So this is the purely Android app. We will be adding the iOS support here using the Kotlin Multiplatform. So we will be doing that from scratch. So because this thing can happen. Suppose you have already production ready app which you are using in the Jetpack Compose, but now you want to migrate that to the Kotlin Multiplatform, or maybe using Compose Multiplatform as well. So we'll be discussing all those steps in this video. So first of all, let's add a few prerequisites for this are like we need to have a Kotlin multi-platform plugin installed in the Android Studio, and second thing is we need the Xcode, right? So we need Xcode as well. So these two things are needed for this, right? So now let's create a new module. File new module, and let's first of all you need to select this Kotlin multi-platform shared module, and let's name it shared, and this will be the package. And so this is the iOS framework distribution point. So how we want to distribute the framework for using the in iOS side, right? It can be regular framework, XC framework, or Coa ports. Three options are there, but by default it uses regular framework, right? So this is very important step. So this step I think we can remove. This will be causing the error, we don't need it, and this one as well, right? So let me tell you a few things about this app. So in this Android app, in Jetpack Compose app, so we have just few data classes like user class is there, data class, right? And login repository is there. In this login repository, what we are doing is so simply we have just login function. We are just simulating the delay there, simple fake delay. So that it will be assuming API is calling here. Then we are returning the response. And similarly in the view model, we have this is logged in user, these state flows, and triggering the login inside this using the repository, right? So you can think of this like the business logic, right? And this is the main activity. So simply here we have the UI part, right? So what we will be doing is, let's go back there, right? So first of all, we can see now it has added these inside the shared module. We can see, so these are the targets. Android target is there, and then these are the iOS targets, right? So here we can add the common dependencies. Okay, cool. So now let's move on to the next step. So before that, let me explain few things about this common shared module. So you can see Android main, common main, iOS main, three targets are there. These are the source sets for these three targets. So not three, actually two targets, Android and iOS. This is the common code which will be shared between both of them, right? So if you see these targets, so for each of them we have these source sets, right? For iOS specific code we'll be writing here, and then this common code we'll be writing here, and in the Android specific code we'll be writing here. So for example, we have this greeting class, and here we are using this get platform. So this function is expect. So expect actuals are there actually for if we want to provide some native implementation like platform specific code for that. So implementation will be platform specific, but we can define that expect class or expect functions inside the common main, and then it expects its implementation from the all the targets which we have in the shared module, right? So here we have Android and iOS, so it will be expecting for both of them, for Android and iOS. So we can see in the Android we have this actual implementation. Whenever we will implement that, we will be adding the actual keyword, and here we'll be using the expect keyword. So here we have implemented this from the Android native code, right? This one, and similarly we have this inside the iOS side as well. You can see UI device, current device, system name. So this is from the UI kit, right? Kotlin native. So Kotlin native is used for the iOS side, and Kotlin JVM is being used for the Android side, So for the Kotlin multi-platform, they are the part of Kotlin multi-platform. Kotlin native is for the iOS, that will be building the binaries for the iOS, right? So now let's continue with that. So after first step is like adding this camera module, right? And then second step is if you want to use it inside the Android main, so we can add it inside the Android main, right? We can implement. So we need to add project here. The shared, right? Really, so that we can use that shared module inside this Android app, right? We are connecting here the shared module to the Android, right? And also one thing, if you see here now, it's showing you a warning. So expect function get platform has no actual declaration in module this iOS ARM 64 main, iOS simulator ARM 64 main, iOS x64 main. So why it's showing that is actually it don't know about those targets. Like if we have defined this, implemented this expect class there. For that, what we need to do is, so for all these three, we need to define the source sets there. So we can define here, let's just pick up them from there. If you see, so it will be the main by getting. So getting means this source set already exists. Some source sets we create as well. This one is also exists, so we are getting it. But some source sets we create here. So we will be creating for iOS as well, if you will be seeing it. So we need to define all these source sets here. Right. And now we need to define creating by creating. So we'll be creating the source set. And so what now is depends on, so this iOS main depends upon common main, right? We need this setup so that we can use the common main dependencies, or sorry, common main code inside the iOS main source set, right? So all this source set will be available inside the iOS main, right? And then we need to make all of these depends upon this iOS main, right? And here we can define any dependencies if we need it, right? So this process also we need. So now this warning will be gone, you will see. Yeah, you can see this warning is gone, right? So now let's come to the next part. So second step will be, so let's first of all test the first part. So we have added the share module inside the Android side. So we can test it if it is integrated or not, right? So we can just, what we can do is, we can print some logs here inside this column. First thing we can do is, here I think we can print some logs. Dash shared greeting, right? Shared module greeting. So here we can just use the greeting class. You see, yeah, it is available. You can see dot greet. You can call this method. So let's try to run it and see. Yeah, if you see shared module greeting, hello Android 34, right? So this one is from the getting, it is the platform specific code. From Android it is Android 34, right? So it's working in the Android. And now let's move on to the iOS port, right? So now shared module is added and it is working in the Android side as well, right? Fine. So let's move on to the adding the iOS port inside this app. So for that we need to add iOS project in this app. So and we can create that using the Xcode. So let's move on to that. So suppose we have this Xcode open, so we need to create one new project. So that is the app iOS app, right? And this can be the package, okay, and this is this, select this UTI Swift, then next, right? Now it's asking for where we need to save, so we can save it inside that app, Jetpack Compose login app, right? Yep, it's done. So if you see, it will update that here very soon. Yeah, you can see this is available now, right? And so after adding this, we need to make few changes in the Xcode. In project settings, we need to add some scripts and all other things. So let's move on to that part. So yeah, if we go here, so you will find few steps here they have mentioned. Make your app multi-platform. So we need to add these few things there. So we need to add new run script phase. Inside that, we need to add this code, right? So this will be doing the embedded sign Apple framework. So it will be creating the framework, right? And this script we need to move it before the compile sources. So we need to move it before the compile sources, right? And the next step will be we need to add this framework search path inside the build settings. If you go here, so we can search it here, framework search paths, and add and click it, right? It's added. And then we need to make one more change. We need to add linker flags as well, right? So they will be helping linking all the source code, right? So we need to copy this and let's go here, other linker flags. So here we need to remember one thing, we should not add it like this. So this way it makes it a single string and that does not work. So what we can do is we can make it inside the different lines, right? And then this shared, okay, yeah, it's fine. And one more thing, so we need to disable user script sandboxing, because so what this option do is actually it will disable one thing. So it will what it will do if it is enabled, so it will sandbox the user scripts, right? It will sandbox our user the script, so it will not allow the input output dependencies, but we need to allow those dependencies, right? So we can disable it, sandboxing, we can make it now, and I think we are done. Yeah, so now it's done, and we need to add one more thing there, and that is static true. This is about how the Kotlin framework will be exported to the iOS app. So currently we are exporting it as static library, right? So now we can sync it, and so we need to add iOS application configuration here, and from the directory we need to go to the iOS app then set the path to this Xcode project file, right? It will pick up configurations, and then we can select the device, and finally we can try to run it. We can name it iOS app. Let's try to run it. If you see, it is the hello world from iOS app. You can see, right? Now, so now we can test importing the shared module, if that is successfully imported for this. Just the same way as we tested it in Android, we see this create method, we can just use this, right? So what we can do for that, we can import shared, and let's say here just try to print great, right? You can see, yeah, it's working fine, right? So now if you see, this is just a simple message. So it's iOS app is also set up with the shared module, and this shared module is working in Android side as well, right? We check that. So now what is the next? So this is if you see, this port is only without the Compose multi-platform yet, right? We suppose you want to share the business logic only, so for that part you can add the shared module like this and set up it as I did the all the steps with the Xcode. So that now it is only the shared module support, right? Kotlin multi-platform support without the Compose multi-platform, because suppose we are not sharing the UI, so then it's fine for us just creating the shared module, linking it with the iOS app, and then using it. Like if we want to create APIs and all other stuff like related to business logic in the shared module, and we want to keep the native UI, so this, up to that point we are done here, right? Just now assume if we need to add the Compose multi-platform UI as well, right? So for that, what we can do is, first of all, we need to set up few things. So I will guide you how we can do that. So first of all, let's change the compose options for Android app, right? First step will be that. So compose options, yeah, because for that, this 1.4.3, this is the version incompatible with the latest version of Kotlin. So we'll be using the latest compose compiler extension, right? And why I change this, because we are going to change the Kotlin version as well. We'll be using the 1.9.21, right? It's done. So now let's add the compose multi-platform, right? For that we need to add the one plugin, that is JetBrains.compose. This is the compose multi-platform from JetBrains, right? And we can specify the version of it, right? And few more dependencies we need to add: compose.runtime, compose.foundation, material 3, all those libraries we need to add in the common main. Yeah, here. So if you see implementation, inside implementation, compose dot, let's sync it first. So in the latest version, we don't need to set this cache kind. We can remove this from gradle.properties, and we are fine. Let's go back to the build.gradle. Now let's compose.runtime. We can include these dependencies, whatever is needed we can include that. Compose.foundation, and we can use material 3 as well, right? These are few dependencies required for compose multi-platform, right? So you might be aware about these if you know about Jetpack Compose, right? This is the another step, and now this setup is done with the common side, so inside the shared module actually. Now we need to make some changes for the iOS part. Suppose here in the iOS side we need to add one class. main view controller, right? And this main view controller will be of type compose. First of all, let's sync it so that libraries will be available. Yeah, so inside this class we can define one function of main view controller that will be of type compose UI view controller, right? This class is basically, this is the entry point which connects the uh, shared module with the iOS app, right? From the, if you want to use the compose, so if you want to use the compose for shared UI, so this is the like entry point. So now what we need to do is, here we can just show the app. This app will be going to create in common main. So actually these are the all steps basically. So now what we need to do is, these are the steps from shared module, right? Shared part. So let's comment it. As of now we will be, while we will be converting the Android code, this code, right? This one code which we have here in the UI. So then we will be creating the app composable in the common main and then uncommenting it. But now we need to make few changes in the iOS side as well. So here side we need to import the UI kit, because we need to create a UI view controller representable class. So let's create that. Compose view UI view controller representable. Yeah. So if you want to use UI kit inside Swift UI, so this is kind of a wrapper for using that inside the Swift UI. This way we can use the UI kit related things. So this will be like make view controller, update view controller. These methods will be there. You can create the view controller object. So this is update the state of the view controller. So you can just go through them, because we'll not be covering that in detail, because this is the only one time setup. After that you will not need to do any setup for this. And so here what we need to do is, let's add its methods, add those methods manually, make UI view controller, this one. And so this is the entry point basically. This creates the view controller, right? So here what we need to do, here we will be, I will coming back to here we will be calling the main view controller which we just created here, right? Func update view controller, right? Here we'll be doing nothing because we don't need to do anything here. So let's first of all build it, or maybe run it first, so that the library will be exported to use in the iOS side. Okay, what it's showing is, yeah, it's asking for return statement. No need to worry, we will be adding that. We can just reduce this area. Okay, and so here what we can do now, main view controller kt, that file will be available as like this, main view controller kt, right? And then main view controller, right? This method will be calling here. Now it will be connecting. So now inside this we will be having all the app content, right? Whatever compose app will be there, common compose UI. And now this function will be called here, so it will be creating the view for the iOS app, right? So now this part is done, and now what we can do is replacing this, all this stuff, because we have created this compose view. This view is connecting the, you can see, Swift UI, right? So now we will be using this view, right? And we can ignore safe area dot keyboard. So this one is it. And now let's say, let's try to run it first. Should not. print anything because we are not printing anything, right? So now just quickly let's say we create. So now connection is done. Compose multi-platform is also set. Now we just need to convert our Android code, right? This one to the Compose multi-platform, right? So for that, what we need to do is let's quickly go to the our all the data code there. This data code, right? So this all data we will be copying it first of all because data will be now going inside the shared module, right? Here, let's add them. Login repo. Let's change the package for all files. Okay, fine. So now this view model. So basically I will be recommending if you want to continuing using the same view model which you are using in Android, so you can use Moco MVVM for that, right? Then you will have to make very minimum changes, right, to adopt to that. I will be adding that in a minute. So this one is this, and now let's pick up this all this code and let's just cut it and call the app here, and this app will be inside the common main, right? Here we will be creating that class app. So here we'll be creating one function. This will be the composable function. Okay, and here we'll be adding all that stuff, right? So now let's comment it inside the main view controller as well, right? Yeah, it's already commented. So now here also it is being used. So let's see what else are there. Few changes maybe we need to make. Import extension function state.get value, right? That is imported. All other things you can see. That's the beauty of migrating the Jetpack Compose app to Kotlin multi-platform with Compose multi-platform, right? Very minimal changes you need to make, but yeah, a few logic related to the view model or those, so which are not the Jetpack Compose specific, then you need to make few changes, but UI part will be mostly the same one, right? So let's remove this, and now let's remove this data from Android app as well because we will be using this. Let's delete this, and so here it is fine. We can optimize imports. So now let's do one last thing quickly. So that is Moco MVVM. Let's add that. If you see Moco MVVM core, this one we need to use. Let's add it. Let's add the implementation part here. Okay, fine. Let's just sync it, and you can see that's fine. Isn't it cool? If you see, I don't need to make any changes, just need to import that, because if we have very minimal logic here, so then it works. But sometimes we have some other things that are Android specific, then we need to make few changes there, right? So let's try to run it now. Wow, it's cool, right? If you see now that app which you were using on the Android in the Jetpack, that was the completely purely Android Jetpack Compose app. Now you have just added a spot of Kotlin multi-platform and using the Compose multi-platform for shared UI, right? If you see coding ambitions, you see login, if you see this is the same functionality which I showed you for the pure Android app, right? If you see, this is now ready with the iOS support. That's cool. And now let's just verify once our Android app as well. What is wrong? Okay, it's asking for something. Default Kotlin is not applied to project shared. explicit depends on. Consider removing depends on calls or disabling the default template. Yeah, so depends on calls. Either we need to remove the depends on calls or we can disable the default template. Right? So we can disable the default template because that default template is app default hierarchy template is enabled by default, and there we don't need to use depends on calls. If you will seeing this thing, if you will be creating the project from the KMP JetBrains wizard, so then you will not be finding the depends on calls. But as of now, instead of removing those depends on, we can opt this way as of now. So now if you try to run it, what it's showing, okay, I forgot. Yeah, 1.5.4 requires Kotlin version 1.9.20, but we by mistake added. Okay, we can stick with 1.9.20, or we can check out the latest version of Compose compiler for 1.9.21 Kotlin version, and we can change that accordingly, right? Either way it will be working. Yeah. Cool. So now we have migrated this Android Jetpack Compose app to the Kotlin multi-platform, right? With iOS support, right? So now one thing I would like to say, that if you so currently you added the iOS support, right? Even if you want to add the now web support or desktop support, so that is also very easy. So for that you can check out my another video how to add web support in Compose multi-platform app, right? So you can check out that video and you can try to integrate the web support as well here. And similarly, the way you will be adding the web support, so similarly you can add the desktop support. That is not that difficult, right? So I will put the link of that video in the description, how we can add the web support in Compose multi-platform app, right? So guys, this is all about how we can add the iOS support to our Jetpack Compose app. So now this is not the Jetpack Compose app anymore. If you see, now this is the Kotlin multi-platform app, right? And using the shared UI with the Compose multi-platform. So what we learned here, first we need to create a shared module, and then we needed to set up the shared module in the Xcode for connecting with the iOS app, and then finally we needed to add the Compose multi-platform, and then finally we were move the logic from the Android to the Kotlin, right? This is the 4-step process. So now we are done with that. So I hope you guys now have the idea how you can add the iOS support to your existing app. So because this can be the case with many developers, because let's say you have some apps in production already and you are using Jetpack Compose there, and now you're thinking of migrating that to Compose multi-platform, right? So that's why I created this video, so that here we created everything from scratch, right? So now one more thing, the way we have used the Moco MVVM for the view model, right? So if you see that, so for the view model we have used the Moco MVVM, right? So that's very similar to the Android view model. And similarly, let's say we have inside the login repository, we were mocking this API call here. So for that, suppose we were using the retrofit, right? Suppose for using the retrofit here, so for retrofit you can migrate to Ktor for Kotlin multi-platform KMP, and similarly for shared preferences you can migrate to multi-platform settings, and for RoamDB you can migrate to maybe SQL Delight or something like Realm. So these are the few things I recommended you, which were required mainly in these some production apps, right? So guys, this is all about how we can add the iOS support to the existing Android Jetpack Compose app. So this might be the requirement for many of you. So we have covered that already here. So this is done. I will see you in the upcoming videos. One humble request, if you like the video, please like, comment and share it. And if you are new to my channel, so please subscribe. That will motivate me to create more videos. So I will see you in the upcoming video. Till then, bye bye. Take care. Have a great time. Keep coding.